Good to see a lot of familiar names from past webinars. Thanks for joining us. If you haven't already, my name is, joined us at one of our previous events. My name's Jordan. I'm the Sustainability Officer at North Sydney Council, and I am responsible for running webinars, workshops around all things sustainability. Tonight, we're focusing on passive house design with Andy Marlow. Just a couple of housekeeping things. Feel free to send, we have a bit of information to cover tonight, but feel free to send through your comments, questions, chat, share your experiences. I think that's what makes it sort of a really good interactive platform. We'll do our best to answer the questions along the way. But we'll also have a bit of time at the end there to answer your questions. And just, if you haven't already done so, can you just pop yourself on mute? Okay. All right. So without further ado, I'd just like to introduce Andy Marlow, who's the architect at Envirotecture and has designed several passive houses. And yes, here to talk us through the basics of passive house design. Welcome, Andy.
Thank you very much indeed, Jordan. I'm hoping everyone can hear me okay. And Jordan will just make sure this thing's going to work and the screens are doing the right thing. Are we the right way around or the wrong way around?
Yep, that's right.
Hey, it's a minor miracle. Excellent. Oh, no, we're jumping around. Fantastic. Okay. All right, I'm just getting myself organized on my screens here. So thanks very much. As Jordan mentioned, I'm an architect. Our company, we have a couple actually. Main company is called Envirotecture. We've been around for quite some time, 26 years, I think it is coming up. And we do mainly residential work, mainly single residential, new builds, alts, ads, and basically lots of other little bits and pieces as well. And we do what I guess we would term sustainable or high performance buildings. The definitions of those things have evolved over the years and probably will continue to evolve. It's what makes what we do quite lovely. We do lots of things all over the country. We're pretty agnostic on location. We actually just like going places, so it's a good excuse to go to other places when you get jobs in places like Orange or Balala, which is our latest one, which is up near Armidale, if anyone's interested. As of a couple of years ago, we started a second company, which is called Passivhaus Design and Construct, and it focuses only on building brand new custom designed passive house certified buildings. We've finished 4 now, and it's going very well. There's been a huge upsurge in passive house interest in the last couple of years, and we're going to talk about what it is mainly, and at the end of that you'll possibly understand and see why the interest is there, and certainly you'll probably have questions along the way. Like Jordan said, sing out if you have questions along the way. I'd much rather we have them as we go along. It makes it closer to being live in a room with each other, which is my preferred method for everything. It's harder to make these things work over Zoom, but we'll do our best. So I'm going to talk about passive house in a couple of ways, but mainly I'm going to talk about it in the sense of the why being the biggest one. That doesn't work for me. So why? So passive house is a way of building buildings that ensures various things, and the important parts are around comfort. So we're talking about achieving temperatures within the house of 20 to 25 degrees. Humidity is controlled, generally from 30 to 70% relative humidity. There are no cold spots and no hot spots. The other and arguably most important part about passive house is around health. So health in the sense of a building, still talking about the health of the humans inside of it. All passive house projects, as you'll see shortly, have dedicated ventilation systems. So you have 100% fresh air, 24 hours a day, 7 days a week. This is one of the ways that we get to ensure that there's no condensation in homes or any buildings for that matter, and also no mold. So these are pretty big reasons to build in a particular way. And they're also, you could argue, very sensible things for people to expect in a brand new building. Many people will have seen new buildings which these things are not happening in, and that's somewhat disappointing, which is why we're very big fans of this particular approach. So one of the biggest benefits to Passivhaus is the fact that it actually does what it says it will do. We can call this quality, which resonates with most people. In industry parlance, it's referred to as the performance gap, or in Passivhaus cases, the lack of a performance gap. The performance gap is literally the difference between what the computer says the building will do and what happens in the real world. And Passivhaus buildings are the most accurately modeled on the planet, in the sense that they do exactly what the computer model says. They're incredibly reliable. If the computer says it's not going to work, then it's not going to work. And if it says it works, it will work. And it's really because ultimately Passivhaus is actually a quality assurance scheme, as we'll talk about in a little while. The process of getting a certified Passivhaus project basically is quality assurance from woe to go, and that's why they work so well, because there is no discrepancy between what you think you're going to build and what you actually build. The data on the screen is actually from a colleague's house in Canberra. It's about 7-8 years old by now, and he just plotted the temperature over a year. And as you can see, this is, as it says there, no cooling. His only heating system is him, his kids. They don't have a dog, and the tail rail in the bathroom. And as you can see, it sits extremely comfortably between 20 and 25 degrees. We can get into a big debate about whether 26 degrees is too hot or too cold, or, you know, if it's 40 degrees outside, 27 is probably feeling pretty good too. But Passivhaus uses 20 to 25 as its benchmark, and that's consistent and incredibly useful. How you use the house is, of course, entirely up to you. So in thinking about why these things matter, it is quite common for people to, especially at this time of year, in fact, kind of do the, well, it's Sydney, it's awesome, we don't really need anything like that. So because it's my nature, I took a look at these things. And so this is the comfort band for Passivhaus, which is 20 to 25 degrees, the dashed lines across the screen there. And then the minimum, maximum, average temperatures for Sydney. And really what you're looking at there is the fact that actually, even though Sydney's pretty darn good, and I wouldn't live anywhere else on a permanent basis, even if you paid me, it's actually not always that awesome. And there's large chunks of the year where it's just darn cold. And I think most people have probably either currently live or have lived in a house in Sydney that isn't particularly awesome. And that for us is why these things really, really matter. The other thing that is actually, I find even more compelling, this data is old, and it was a particularly hot January, a hot and very muggy January. I remember it well because it was our first summer in our current house. And basically what you're looking at there is what the bomb say happens in Sydney in Januaries and what happened in that particular January. And basically it was hot. It was hot all month. And more importantly, it never cooled down at night. And therefore everything just gets warmer and warmer and warmer. And you end up effectively living in what begins to feel like a kind of old school brick pizza oven, which is great if you want to cook pizzas, not so good if you have small children, or actually if you just like being comfortable for that matter. But yeah, the younger or older you are, the more those things seem to resonate. So health, comfort, quality, be it whether you look at it as quality assurance or getting what you pay for, plus the fact that Sydney's climate, especially as it's beginning to change and become more varied, a whole bunch of these sort of big picture reasons as to why we think these things matter. So having talked about why, about something I haven't explained very well yet, your next logical series of questions will be, well, what the hell are you talking about? So let's have a quick look at what this is. So Passivhaus is best described as a fabric first approach. It is quite literally insulating the indoors from the outdoors. You could simplistically describe it as an esky. We're trying to control what happens in order to use as little energy as possible to maintain comfort. And by maintaining comfort, we maintain health. The one thing I didn't say at the start is passive house is really about health and comfort. You can't be healthy if you're not comfortable. It's impossible to be healthy if you're sat in a room and it's 35 degrees. It just doesn't work physiologically. So all of these things are intrinsically linked. So, wrong button. So these buildings are designed to deliver optimal indoor energy efficient environments with minimal input from active systems. What does that look like? So this is a lovely series of cartoons by Not Me. So 19th century, put stuff inside and burn it. Some people still do this. Not particularly great for the neighbors. Lots of issues with smoke, winter smoke causing issues for other people outside of the individual house. It's got the wood-fired heater. 20th century, this is a fairly accurate representation of some buildings. Lots of things became very complicated, and arguably lots of them didn't really need to be. But it was good for people who understood them because they could charge lots of money to make things very complicated. And the way that most people now perceive passive house is actually we've simplified the bejesus out of this, taken it back to the things that we really need to happen, which really are around good design, simple delivery of fresh air, and on the whole, especially in our climate, nature can do most of the other things for you. So it's a lovely little graph. In explaining passive house, one of the things that is often mistaken is because it's the German word house, actually translates to building. It's not necessarily only about houses in the sense that we think of a single building in which, you know, a small group of people live. There's a myriad of examples around the world of very large buildings. There's a university in Melbourne that's currently the largest certified passive house in the Southern Hemisphere. At Monash Uni, I actually forget how big it is, but we're talking like tens of thousands of square meters. It's completely agnostic as to what the building function is. There's a bunch of swimming pools that are technically extremely challenging buildings anyway. So you can apply the same principles to anything. So this is a lovely building in Bilbao in northern Spain. Happens to be social housing, pretty good looking social housing too. And this is an awesome looking place. It's a old brutalist building that's becoming a hotel in somewhere in North America that I've forgotten. It's a retrofit project, so you can apply retrofitting passive house principles and get passive house certification for retrofit projects as well. So it's not only about new buildings. So yeah, this is technically just complicated beyond belief, which for people like me is quite exciting. For most people, it's just going to be a really comfortable hotel, which is fine because ultimately buildings should just be comfortable. So this is a bit of the why and the what in the big picture sense. How do we make these things happen? So there's 5 key principles to all passive house projects. And they're applied differently because it's about meeting a particular benchmark for your building at your place on the planet. So the benchmarks are the same wherever you are, whether you're in Sydney, Melbourne, Darwin, Berlin, Antarctica, anywhere in between. The benchmarks are the same, and therefore the solutions can be wildly different because obviously your climate's wildly different. A building in Darwin should look wildly different to a building in Berlin. But the way that we make them work is the same every single time. So first is insulation, and we refer to it as appropriate levels of continuous insulation. So they're not necessarily high, and in Sydney, they're not particularly higher than what you need for code compliance with the building code, but they need to be continuous, and basically that just means done properly. So not particularly difficult to achieve. Doesn't mean that it's done well generally, but not very hard. The part that's arguably the trickiest and will almost definitely generate the most questions is around airtight construction. So the passive house needs to be airtight. It needs to be airtight to the extent of achieving a blower door test rating of no more than 0.6 air changes per hour at 50 pascals of pressure. So that's leaking 0.6, so 60% of its internal volume in an hour, and 50 pascals of pressure is about the equivalent of a 33 km/h wind. So it's a bit of a breeze, but it's nowhere near a hurricane. Just for reference, the average new Australian home, according to the CSIRO, is 15.4 air changes per hour at 50 pascals of difference. So a passive house is, on average, 23 times less leaky than your average new Australian home. Now, obviously, average new Australian home's got some wild numbers in it, so there's, averages are averages, but it is significantly more airtight, i.e. less leaky than your average home. So the third principle is around minimizing thermal bridges. So thermal bridge is anything that that conducts heat from inside to outside. So in winter, that's generally sucking heat out of the building, which you can also think of as pulling cold into the building. And in summer, it's the reverse. So the biggest culprits in Australian homes are windows, in particular aluminium frames. So if you sit next to an average aluminium frame window in winter, you will feel the cold coming off it on the inside, and then you start to experience discomfort purely because you're sat next to this thing that's pushing cold air towards you. And even if the room temperature is actually quite warm, if that aluminium frame is particularly cold, you'll feel uncomfortable, even if the air temperature suggests that you should actually be comfortable. So thermal bridges can cause discomfort for humans, which is one aspect. And the other potentially worse aspect is that they can also, due to the nature of a cold thing inside a warmish building, they can also be the source of condensation and mold. And again, windows are a good example, whether it's aluminium framed windows and getting condensation on the aluminium itself, or whether it's just single pane glass windows. And again, in winter, overnight in particular, the propensity of them to get often quite large amounts of condensation on the inside. Obviously, then it depends where that water ends up. And I suspect there's probably nobody here this evening who has not seen that happen at a house in Sydney. It's incredibly common. So minimizing thermal bridges is partly about comfort, partly about health, and partly about not damaging your building, because it's fairly annoying to spend $1 million or whatever you might spend on a house and then have the whole thing start to rot and fall apart. So the fourth principle is around high performance glazing, and it's obviously linked to the thermal bridges to some degree, but it's really about the fact that we have these windows in our walls and we want to make sure that they get us some nice warmth during the cooler months, so that you get some nice solar gain in wintertime to warm your house up and warm yourself up. But also we want to not lose that heat during the latter part of the day. There's not much point getting all this sun in for 4, 5, 6 hours in the middle of winter if for the next 18 hours it just all bleeds out at a horrendous rate and you end up in a worse place than when you started. So in Sydney, this generally translates to having double glazed windows. We have done a few projects in Sydney where we've used triple glazed. We actually used them because they were cheaper than the double version, which I'm sure somebody will ask me about later. But the triple glazing generally isn't required. We just use it because it was cheaper. So yes, and the frames, in terms of the window frames themselves, Passivhaus is agnostic on what they're made from. They just need to work. Most Passivhaus projects are made with either a timber window or a timber aluminium composite windows are very common, mostly imported at the moment. Which is a solid timber window with basically an aluminium cladding on the outside. They look pretty schmicko. And the good thing about that is you get timber look on the inside, you get aluminium on the outside, so you get the longevity and lack of maintenance from the aluminium. But the window really, in terms of thermal performance, is timber, which is pretty fantastic. The other ones that are really common are UPVC. Some people have a deep-seated aversion to UPVC. It's got a pretty awkward history, shall we say, in terms of environmental performance, not in terms of the window, but in terms of the impacts of the production of UPVC over history. That's come a long way and improved a lot. And at the moment, they are incredibly cost effective if you want a high performance window. So lots of people are using them just because in the scheme of windows, they're really cheap and they're really good. So we use them on a lot of projects. And then finally, the fifth principle behind a passive house is mechanical ventilation with heat recovery. So the questions that I'm expecting to get are around, if I have an airtight house, then basically, how do I breathe? So firstly, it's not that airtight. You're never actually going to suffocate. But more importantly, it's around the quality of air inside. And you're right, if you make an airtight house and you don't have reliable ventilation, then it's going to be fairly horrible. And there's a pretty good chance you get condensation and mold as well, because you're going to get you're going to get moisture building up inside the house. So a mechanical heat recovery ventilation unit, they come in various shapes, sizes, forms. But in new builds in particular, they will tend to be a central unit. They pump fresh air into all of the living and all the places where people spend time. So living rooms, bedrooms, studies, that kind of thing. And they pump fresh air into there 24/7, low volumes, but always putting fresh air in. And at the same time, they're pulling out all the what we call dirty air, or basically air from moist spaces, bathrooms, laundries, kitchens. And that air is getting thrown out of the building, new air is coming in, but there's a process in the heat recovery unit where they're taking the heat or the heat energy from the outgoing air and putting it into the incoming air. So it means that in winter, if it's about 20 degrees inside and it was about 0 outside, it means that the fresh air coming in takes the heat from the 20-degree air leaving. So the air that would come in at about 18 or 19 degrees, which is slightly cooler than 20, obviously, but significantly better than 0, which is what you'd get if you opened the window for fresh air instead. And it works exactly the same in summer, but obviously in reverse. So 20 degrees inside, for example, 40 degrees outside. So your fresh air coming in is going to be coming in at sort of 22-ish, which again is significantly better than a window and 40-degree heat coming in through. So they're incredibly efficient systems. They use about the same amount of energy as a halogen light globe, which is, and that's for an entire house. So yeah, not much. And it's one of those things, kind of like an electric car. Once you've experienced it, it's pretty hard to go back to the other ways of the world. So what I might do now is talk a little bit about the process of how these things come together. The process of designing homes is complicated. For those of you that have done it, it's, you've probably got a few stories about the trials, tribulations, the ups and the downs. This is really about the passive house specifics of them. So I just want to talk around a couple of the sort of terminology bits that you'll see if you ever start going down this route. So there's a bunch of certifications that are issued by the Passive House Institute, who are based in Germany. They're the one that came up with the standard. They're the one that basically run the certification process. And they have these 3 different types of certifications for humans, not for buildings. So tradespeople, designers, and certifiers. You don't, in order to get a certified passive house, you don't have to have a certified designer or a certified tradesperson. And that's fine. It can be argued there's an advantage to it. Obviously, someone who's done a course knows more than someone who hasn't, but not having done the course in and of itself is not fatal either. Everybody does something for the first time, so it would be remiss of me to say otherwise. Look, we seriously think it happens to help to have done it before. We certainly know all the pitfalls that we've, and rabbit holes that we've been down in recent years that I'm now glad I'll never go down again. But, everybody's always learning, and we're always learning. So at the moment in New South Wales, I did check the other day, there's 44 certified tradespepeople and 57 certified designers. So in the scheme of people designing and building houses, it's still a fairly small thing. But those numbers have probably quadrupled in the last 18 months. So it's on I didn't make a pretty graph, but you can imagine what it would go like. Yeah, they've gone pretty stratospheric, and that's basically because people have cottoned on to the fact that this is a pretty good way to build things, and also not particularly difficult in the scheme of things. I mean, building houses is hard. Building them well isn't much harder than building them badly. So if you want to build one of these things, what do? Well, you start by designing a building, and you may or may not use a certified designer to do that. That will be entirely up to you, but you need a building design. We then run, somebody will probably a certified passive house designer would then run your building. So this is, as you can tell from the image on the screen, a very simple version of a house. This is not what the house will look like, but this is all we need to do in order to be able to analyze the model. It cares about the walls, roofs, and floors, which are the red bits you can see. It cares about the shading, so the grey bits you can see, the windows, obviously, and then things like trees and any neighbours. This place didn't really have any neighbours. So this is the model that gets analysed in order to then work out how it's going to perform. There is a piece of software that in the passive house world is referred to as the PHPP, the Passive House Planning Package. It is, I don't know if it's it feels like the biggest Excel spreadsheet in the world. It probably isn't. In fact, it won't be. But it is an Excel spreadsheet. It is not the prettiest looking thing, but gee, it's really good. And I've just realized that I didn't take someone's address off this. Anyway, so this is the one for the passive house that we did at Thornlea, which is the first one in Sydney. And basically all the data about the house, about the windows, the walls, what it's made of, all of this information is contained within this piece of software. It wants to know about the hot water system you've got, whether it's inside the building or outside the building. It wants to know about heating and cooling systems. It's pretty intense in what it wants to know or needs to know. And it's one of those things, like most computer programs, it's, garbage in, garbage out. And therefore it asks a lot of questions. They're very detailed, and therefore you get really good detailed answers out of it. So again, most people would have a certified designer do this piece of the work, but again, you don't actually necessarily have to. During this phase, this is when you get to optimize the building. So we spend a lot of time in software basically tweaking and changing, whether it be changing shading, looking at the type of glass we're going to use, looking at whether we do or don't have external blinds to control shading, etc., etc. So there's lots of opportunity to improve buildings in this phase, and generally most of this you do before you go to council for approval. We help quite a few people who come to us after they've been to council with like designs by other people and kind of go, oh, we've just discovered this thing, and can we make it a passive house? The answer is nearly always yes, you can. The issue normally is that it's trickier than it would have been if you'd started earlier. It really, once you locked into things like window sizes and window placements, it's not necessarily harder. It just gets more expensive because you have to throw more technology and materials at things to solve problems. Whereas if you can get in right from the start with someone who's done a few, then you can really optimize the building, make the best of both worlds. So once you've worked out exactly what you want your building to look like, you need to document the building. This is a graphic from a house I'll show you some images of in a minute. It's the smallest certified one we've done. It's a little granny flat in freshwater on the northern beaches. And what you're looking at here is the layout for the heat recovery ventilation unit and how it works. We had to work this one out in painful detail. As you will see, there's not a lot of room because it's a really small building. And that's fine. It just took a lot of planning. But the point is you need to document these things in order to head towards getting your building certified. What happens once you've got your documentation ready is that you would normally then go to your passive house certifier. So this is not the same certifier that you have for complying with various building code things. This is a totally different kettle of fish. There's not very many of them. That's not a problem, but there's not many because the industry is still growing here. And their role, the certifier's role is to review all of the documentation, ideally before you start construction, although you don't have to. You can do it once you've started. You just obviously introduce risk at that point. And they review everything. And what they're really doing is they're looking at the drawings of the building, the specification, the insulation, materials, glazing, etc., comparing that against the drawings, comparing that against the PHPP, the modeling of the building, and basically saying all of this is the same, it all lines up, it all makes sense, everything's correct, and therefore, so long as you build it like you say you're going to build it, and you pass your blower door test, and you commission your HRV, your ventilation unit properly, then you will become a certified passive house. So you basically know before you start that all being good and well, you're going to get over the line at the end. So after that, then you start building. This is an image of the Thornley house. This is red, but it doesn't stay red. I've realized that the red image in the other images can sometimes confuse. The house gets built in many ways. That's not wildly different to building any other house. It's made airtight. In this case, the red rat is the airtight membrane, but there are many different ways to do it. Passive House is really agnostic about how you achieve awesomeness. It really doesn't care as long as it works and is safe from a health and point of view for the occupants. So it's incredibly flexible. That's lovely. You could argue that the downside is that there is therefore no one answer to any question, and therefore it's not that everything's bespoke, but there's a lot of possibility. Some people love that because it introduces variety and excitement and difference, and other people find it frustrating because it just means that there's no quick answer to anything. Once it's built, there is a blower door test. This is what these things look like. So it's basically a canvas thing stuck in a door, big fan at the bottom and hooked up to the computer. And all it really does is you tell the computer how big the building is in terms of its volume and its surface area. You then set the fan running. The computer works out how much air is flowing through the fan at different pressure levels. It then computes what that translates to as an air change rate for that volume of building at particular pressures, and therefore you end up with a result. They're really quite exciting the first time you get to see it. Once you've seen it once, they're fairly mediocre and a little bit dull. The most fun ones are actually the buildings that leak. Passive houses are actually really hard to test because they're so airtight. So they actually end up with much smaller fans because that fan in the image there is too big. But also, like, nothing really happens. Whereas when you test an old leaky building, it's much more fun because you can go around and squirt, what's it called? Talcum powder. Talcum powder is really good because it's nice and light. So you just squirt that near things where you think it leaks. You can normally feel the air whistling anyway. Yeah, really good fun. And the other one is disco smoke machines. So every blower door tester pretty much has a disco blow, not a disco ball, they might, but that's got nothing to do with this. And they pump smoke into the building, and then someone else, while this is happening, stands outside, and you just wait to see where it comes out from. And sometimes it can be really interesting as to where that is. Often it's really dull and it's just around the windows, but sometimes it's really funny places. So yeah. So you do your blower door test, you commission your HRV unit. I don't have a picture of that. But basically it's just having someone who knows what they're doing, make sure the thing's set up properly. It's delivering fresh air into your house, and therefore it's pretty important to get that right. And once you've done all of that, you get certified. You get this lovely plaque to stick on the front of your house if you so wish. And then you live comfortably and happily in your house for forevermore. That's the process. It's fairly straightforward. And like I said, really, it's focused on quality assurance as much as anything else. And I guess, because I haven't actually said it, as an architect, like our reasoning for certification, our reason for advocating for certification really is because, well, it's our clients having comfort and knowing that they're getting what they're paying for, which doesn't mean they don't trust builders or trust us, but it's just nice to know. I really like it because someone makes sure we haven't made mistakes. We're human, and every now and again we stuff up, and generally not very badly, but it's just nice to know that someone who's generally, in fact, in all cases, much smarter than me, because these people are very, very, very clever. They're checking what we do to make sure we haven't made mistakes, and I find that comforting. and most of our clients are tending to agree. So yeah. I've got some slides to show about the little Laneway project, but I see a bunch of questions. I might do some questions if you don't mind, Jordan, because I wouldn't mind hearing from some other voices. I can't hear you speak. You're on mute there.
Oh, sorry about
That's
that.
all right.
Yeah, they're coming through fast and furious now. So I suppose we'll take the first question related to the when you're retrofitting costs. Is it to retrofit a passive house? Does it cost more than to do build? Yeah.
Incredibly hard to answer. It depends how you measure cost. It's like retrofitting can be expensive because it's fiddly, and fiddly ends up being about labor. So yes, it can be expensive. The tricky things with retrofitting depends on the condition of the building you're starting with as first point. Depends what it's made from. Retrofitting timber frame is easier than retrofitting masonry buildings, but both are possible. We find in practical terms in Sydney, the biggest thing that actually ends up dictating the difference is how much bigger people are making the houses. It's really uncommon here for people to actually retrofit a house. They nearly always retrofit and make bigger. Right. And I'm not saying that's a bad thing, but what tends to start happening is once the bigger bit starts to occur, then you do tend to hit a point where it's like, it's just going to be more cost effective to knock it over and start again. Yes. So that can occur. Obviously that doesn't price in anything to do around like embodied energy and all the existing stuff in the original house. So look, it's really hard. I'm unsure whether D is who D. Anyway, but yes, it's very hard to actually answer. Retrofitting can be expensive for sure. But yeah, many factors. Doesn't mean it shouldn't be happening. We've got a lovely job actually out in Orange at the moment, and it's orange. Like the house is huge. It's a 80s brick house. It's fairly ugly, to put it mildly, and brick veneer, but it's massive. Yeah. And they're like, we don't need it to be any bigger. In fact, if it was smaller, we wouldn't really care. And therefore, it will actually potentially be our first true retrofit job, because all of the others have always involved changes in size. But the good thing when it's proper retrofit is you don't need to tell anybody, because it's just maintenance. Yep. So you don't need to go anywhere near council, and that'll save you tens of thousands of dollars. No offense to North Sydney Council or any other council for that matter. But it's a big factor in the cost. So
sure.
Yeah. Go on, Jordan. Do you want to read them out?
Yeah, sure. So I suppose you sort of covered it with that answer to the last question, but what Anne asked, what happens some years down the line if an owner wants to renovate? I suppose that's sort of similar to the retrofit question.
Yeah. Look, and it depends what you mean, what means by renovate. Like if it's somebody wanting to refit a bathroom, then go for it, refit your bathroom. Ditto for a kitchen and anything else. If it's about extending the building in any way, making it bigger in whichever direction for that matter, really the only factors are making sure that the new bit is built so that it's still airtight, resolving the ventilation system to make sure that the new parts of the building are still getting good ventilation through the delivery from the mechanical system, and I mean you'd also model it to make sure it's still going to perform properly, because it'd be fairly odd to take a awesomely performing building and then deliberately, or do things to it without checking to make sure it's still going to work. So yeah. So not particularly difficult. Hasn't happened at all yet here. Hasn't happened that much overseas. The very first passive house is in Germany. It was 30 years old sometime quite recently, and yet hasn't really changed. And they've been testing everything in it, and it works like it did 30 years ago. It's kind of cool.
And the test of time. Yeah, it's really what a house should do. But anyway,
staying positive.
Carla asked, what's the cost to certify a house? Are there any rebates at all?
No, there are currently no rebates for this, because we as a nation didn't vote for people who do that. The cost of certification for a single house, the certified part would generally be around $3,000 to $4,000. And then you also have to be, well, you obviously have to build the thing anyway. Let's assume you were going to do that. There is a few extra bits of paper chasing and proving that gets done from the architect side, designer side, or the certified designer side, whoever plays that role. That's not actually that huge. And I'd certainly put that in the quality assurance bucket of stuff you want them to do anyway. So look, probably $5,000 would be what you'd actually show out over and above. And if someone hasn't already asked, they might do. There's very little reliable data on the cost uplift of these things. No one sells them. I think that says more than anything else. Every person we know that lives in one, or even a lot of the houses that we did 10, 15 years ago that worked pretty darn well, everyone's question is, well, where would I go? Unless I want to build another house, I don't want to live in anything else. So I think in some ways you could argue they're priceless.
That's interesting. Annalise asks about, can you recommend any good HRV systems? Do you have a personal favorite?
I do have a personal favorite. Look, there's a bunch of very good brands, and they're all as units pretty much very, very comparable. We only use PHI, which are the Passivhaus Institute certified units. They test them in a different way to all the other international standards, and to put it simply, their testing regime is good. Everyone else is a little bit odd. The one that we use all the time is a product by a company called Zender. To be honest, they're as good as a couple of the other brands. Stiebel Eltron get used a lot as well, which is another. They're all European brands. Everything, none of this stuff is made here. I heard today on a podcast only 15% of building materials that we use in Australia are made in Australia. So yeah, not massively surprising. And look, the Zender one, to be honest, we use it because I like the guy that I deal with, and he's reliable and gives really good service, and he charges about what everyone else charges. So I'm pretty loyal like that. So, but yeah, nothing wrong with a lot of those other ones, but that's my personal preference.
Fair enough. Good question from Terry about, are there any Passivhaus design sort of apartments, or does it same principles apply for?
Yeah, exactly. It's actually easier. The bigger the building gets, the easier it gets, because you've got less external surface area to volume. So there's a lovely example in Redfern. Wonderful builder architect called Oliver Steele did a project known as the Fern. He sold it at the end. I haven't checked for a while. It's used as serviced apartments. It's right next to what's it called? Technology Park at Redfern, and there's a bunch of office stuff there. So he sold it just before COVID, which was a bit of a blessing. But you can go rent them and stay in them for a night or two if you want to experience what it's like. In terms of other stuff, at the moment, there is nothing that I know of for sure that's getting built to Passivhaus standard. There's a lot of interest. Victorian state government's doing really good stuff with social housing, and probably going to build some of theirs to Passivhaus standard. New South Wales government, less awesome. And a lot of developers, especially in what's known as the build to rent market, are also looking at it, because build to rent involves the developer owning that building for forever. And they therefore have an interesting quality, as opposed to the people who just sell them, who you could argue have minimal interest in quality. And therefore that end of the market's going to really push it. So yeah, answer is they're coming, but not yet.
Yep. It's Perry's question about the challenge of how big is the challenge of balancing warmth in the house, a passive house. Is it a house? Passive house heating through glazing on a heated concrete floor.
How big is the challenge? If I follow the question, Perry, turn your thing on and talk if you need to correct me.
Jump in, Perry, if you want.
But if I think you're saying what you're saying, not very hard. it's actually really easy to make a passive house work in Sydney for winter. You don't need to face north. You don't need thermal mass. You just need a really well-built building. The biggest challenge is keeping them cool in summer. So the flexibility from a design point of view, which I didn't talk about at all, is huge.
I think that's really important. That's, I mean, considering, the way a lot of blocks are, the way they're situated, it's, that's really huge.
Yeah, of the 4 that we've finished that are certified, 2 of them have the street to north, which is not ideal. 2 of them are pretty good from a passive solar point of view, but the other 2 are fairly terrible. And we're working on like retrofit things, especially like we've got a couple in the inner west, like terrace houses. They're orientated in the wrong direction. They've got a 2-story building on the boundary. Like, they're just, from a passive solar point of view, they're terrible. Yeah. But because our climate's pretty good, if you wrap them up well, make them airtight, and put a couple of people in a fridge inside, you're good to go.
Yeah.
So, yeah.
Back to cost again. Cost of a new passive house compared with the cost of a new standard house.
Nice question, Trina. I'm surprised it took us this long to get to
that one. Exactly.
Look, there's a paper on our website which is called Passive House, What's It Worth? If you Google Envirotecture Passive House, What's It Worth?
I'll send that round in the email follow-up.
That'd be good. Thanks, Jordan. It tries to answer this question in a lot of detail, and it uses the numbers from the Thornley house that we finished, which was the first one, in order to try to answer it. The key thing in the question is it depends what you mean by a standard house. If you mean a project home, then it doesn't really matter. The question's unanswerable because a project home company is literally unable to deliver the quality that you need. Their business model is not set up for that, and there's a big explanation as to why in the document. If you're building a custom designed, custom built house in Sydney, then the cost uplift should be somewhere between nothing and about $20,000 bucks. And that's because you'll buy a ventilation system. You'll get changed from $20,000 bucks, but I just picked that number. You should actually also end up with a lot less air conditioning as well. So that's normally why you'll end up back to zero. The cost really is in quality construction. And as soon as you're building a quality home, then it all doesn't make much odds. It's just having good design. Good design doesn't cost a great deal more than bad design, as long as you cost the right people. And therefore it shouldn't be costing much more. So yeah, zero is my short answer.
Yep. Does a passive house designed have to have closed windows, doors all the time? No. A common question as well. Yep.
It is. Yeah. No. I like these ones. They're sensible questions.
Yeah. Absolutely.
The short answer is no. If it's I didn't go out much today. No, it was nice today. Yeah, it was a bit humid actually. If it's nice outside, open the doors and windows. It's not going to do any harm. However, if it's 40 degrees or zero, you can still open your door and window like you can at the moment, but don't be surprised if your house gets hot or cold. So it doesn't really you can operate your house however you want. The thing to say about the ventilation unit is you never turn them off. There's no point. They don't use much energy. They don't make any noise. So if you turn it off, there's a fairly good chance you'll forget to turn it back on. The thing that will happen if you turn it off is you will notice about, depending, maybe 4 to 6 hours later, because the air will feel different inside the house. And at that point, you'll be like, we turned it off. But no, you can do whatever you like with these houses. So,
yeah. I know you mentioned before that, I think a couple of owners have Yeah, they use a house in a normal fashion. They like the fresh air or the air coming through. Sorry, not fresh air, because the air comes through the system, but the air come like the breeze, and so they'll just use it in a normal way that normal people use it at other houses or regular houses.
Yeah, I mean, at the end of the day, the house will still get a little bit, like in summer, it'll get a little bit warmer during the day, and it'll start to cool down a bit towards the end of the day. Like it'll behave in a not dissimilar way, just in a much tighter band of performance.
Yeah.
And the house, actually, the screensaver thing behind me, I've just remembered what's on, is the Thornley house. Behind those water tanks in the image, there's two huge windows that open. And myself and my partner happened to stay there over Christmas a couple of years ago because the clients were overseas. And at the end of a warm day, because we were there in the middle of a huge heat wave, it was like 47 degrees outside at one point, according to the sensors he's got. Like you open up those windows and the breeze comes ripping through, and it's whatever it is, 20 degrees outside, and it's just fantastic.
Yep.
So yeah.
Right. Question about passive solar heating. I think we touched on that before. So yeah, the house doesn't require passive solar.
It depends on climate. So in Sydney, no, you can pretty much get away with it. But obviously, like if you went up to the Blue Mountains, it's different. No. It's still nice to have it. I mean, just from a human delight point of view, it's nice to be able to sit in a chair in the morning, drink your cup of tea in the sunshine, while being warm, rather than having to go outside and freeze your bits off. But yeah, you can make almost anything work. Is the short answer. If there's like zero solar access, you end up needing more insulation because you need to hang on to the heat that you've got for longer because you've got less free input. So that can add to the cost of building. In a potentially strange but useful twist, it actually makes for a more resilient house because you're living in a tighter, better insulated esky. So there's trade-offs, but it's certainly possible. The best thing I reckon is that there's a huge opportunity to, if you were somewhat minded to be doing this to make money and had money to finance it, in buying really mediocre sites. And I think in the apartment market, that's what they will eventually twig to, is that you can buy a really mediocre location, make it work like a charm, and pay a lot less for what everyone else thought was a terrible block of land. So yes, anyway, once my lotto win comes through, he'll be having a crack.
Okay, so I think that's all the question. We've got 5 minutes left. Do you want to talk us through the...
Yeah, I'm going to assume people have a bit of an interest in that, so sure. So look, this is, hang on, gotta get back into moving slides. This is we call it Passive Laneway. It's a little granny flat. It's in freshwater, which in a bizarre twist of planning regulations has a few streets with laneways, which are incredibly common in the inner west and inner city, but slightly weird in freshwater. Anyway, our clients happen to own a house which backs onto a laneway, and we built them a passive house granny flat. This is a drone shot. You'll see a shot from the other side in a minute to understand why it's kind of hard to picture. It's small, depending on your definition of small, it's 60 square meters. North is bang up the page. So this is one of the ones that has really good orientation. And you can see that it's quite sort of convoluted is not the right word, but it's not a box. And that's mainly due to planning regulations and needing to be set back and not breach height planes and a whole bunch of other things. But it's got 2 bedrooms, a bathroom, a kitchen and a living room. It's got all the things you need. The clients, so they're a couple, they have no kids. They moved out of the house and they now live in here and they rent the house out and they're much more comfortable. They did it as a 6-month trial when they first got the place because like we want to live in it before we rent it out. They lived in it and they're like, we're not going back to that house. And we'd already renovated the house and the house isn't bad, but this is just much better. So they're staying. So anyway, someone else lives in the other house. I just wanted to show a few images of the construction just so you can see that in some ways it's different, but it's mostly not that far removed from everything else. What you can see at the bottom here is what is a almost a triple car garage. It's got 2 car spaces and a swagger storage space, and the granny flat sits on top of it. So the garage is all split face blockwork, as you can see there, and then everything above that is timber. So that was the timber frame. Timber walls up. It's the same red membrane that we used on the other project, which is acting as both a weather barrier and an airtightness barrier at the same time. Then we've got a shot. We've jumped forward a bit into time, but this is how the ceiling was put together. So the roof is insulated. You can see the polyester bats up in the roof there, and then this is a sheets of PIR, which is a rigid insulation board. It's got a foil face on it. And I think I didn't take the photo, put the photo in, but all of the joints of that get taped. And that's how we create airtightness on the ceiling in this particular building. Like I said, there's many ways to do it. This particular series of things being put together, we haven't done since, not because it wasn't good, but just because this worked well here, and other things have worked better in other places. So that's the ceiling going up and then getting sealed up later. I put these in just to show this is actually ends up being where a light fitting goes and a power point. But when you put a hole in an airtight building, you need to seal your hole in the airtight building, which is sort of obvious, but not unless you think about it. So you can see that what happens is every time anything goes through it, you firstly try to minimize it because it's more work. But they tend to put a conduit through. You can see a whole bunch of sealant around the conduit where it goes through, and different location. But basically, once whatever you're putting through is in, then you goop up that hole as well, so that the building can remain airtight. So it's things like that that add a little bit to the construction time. Obviously, they're also what add to the building working. This is one of a couple of images about the ventilation unit. So you can see these on the left here, that's going to the outside world. You can see the daylight coming through, and that's one's to bring in fresh air, one's to exhaust the stale air. The unit itself is sort of missing in the middle at the moment. Not now, obviously, but in the photo. And then this is actually a whole bunch of preformed ducting, which gets used. This is a particular unit, same brand, but it's designed for apartments. So there's a lot of sort of modular clip together bits, which is both good because they're space efficient, but means you've got to plan the thing to make sure they actually work because there's not much room for error. So air is getting distributed through those. And then this is basically lying on the floor of an unfinished bathroom staring at the ceiling. But what you're starting to see here is the air is coming in through this bit in the top right-hand corner, which is that box, which is leading eventually from the unit that was missing in the previous image. And then all of these white ducts are what deliver the air or move the air around the house. So every space has air or has an air duct to it. And depending on whether it's a bedroom or a bathroom, it's either supplying or extracting. And it's quite different conceptually to say air conditioning, where you have this, you start with a really big duct and then you branch off it. It's really hard to control what happens with that because you've got no way of changing the airflow in a particular space because it all starts from the same place and comes through the same system. Whereas here, because every one is unique, you can adjust and tweak each of the outlets, which are not in this image, but that go where that red cap is, and therefore you can adjust the airflows quite accurately. And that's the commissioning process as part of the certification, because you want to make sure it's actually going to work, which again sounds obvious, but is for the inexperienced is quite easy to get it a bit wrong. So that's the sort of the construction part. The rest of it is just building a house. It's a very nice house. And then there's just some nice pictures. So it happens to have a lot of very beautiful timber cladding. These are the doors. These are double glazed door. It's got the aluminium on the outside. And if I find, that's a very nice staircase that has nothing to do with it being a passive house. I just like the stair. And that's those same doors on the inside. So you can see the timber. This is what's called finger jointed pine. You can see how the pine's all sort of jointed together, hence the phrase finger jointed. I really like it. There's a myriad of options. It's Windows. There's thousands of options and colors and handles and bits. Yeah, and then yes, and then finally, that's just a shot of the kitchen. It's got a recirculating range hood, again with same windows or same style of windows. Just a fairly standard looking house. So yeah, there's a question there. What's the difference between the red boards and the blue boards? Blue boards, I don't know when that came in. Red and blue.
I think that was to do with the outside wrapping of the, yeah, that. So the, is that, I think, is that what you're talking about, D? Yeah.
D?
Well, some of them were maybe, I think one house was blue.
Standard buildings use blue board. Oh, you mean blue board. Oh, okay. No, this is totally different. So blue board is fiber cement sheet, which is a cladding material. And that's a cladding material. This is about the board you can see at the back is called OSB, which is orientated strand board. It's in some ways, it's not dissimilar to plywood. It is different, but it's near enough. It's in this case 6 mils thick, and it's about bracing the building so that it doesn't fall over. And then it's also about this membrane, this red stuff is sticky. So it needs a surface to adhere to, and hence why we wrap the building in the OSB and then wrap it with the red stuff. This is about keeping water out and keeping air in. Blue board is a cladding material, which has got nothing to do with either, really. We could have clad the building in blue board. It's just, you know, the timber's much nicer.
Yep.
So,
right.
Yeah.
Well, thank you so much, Andy, for taking us through all the basics there. And thanks to everyone for all your really good questions. Glad to see that you enjoyed the presentation. So thanks for the comments, everyone. I'll be getting a few messages about getting Andy's details. So I'll pass that on in the email follow-up with the Envirotecture website. So you can contact him if you wish. So yeah, thank you again. And yeah, thank you very much, everyone. Have a good night.
No worries. Thank you, Jordan. Fun as always.
Yep. Thanks, everyone.
Bye.